8.7 Objective. Use function notation. Function notation just means when a function y is represented by f of x. This just means that the value of the function f will be a number y at the point x coordinate x. For example, f of 3 is the value of f when x equals 3. So we could look at this in a little differently. X, f of x. And this would be your y coordinate. I could actually use any letter to represent the function. For example, g of x. It still represents a function. Okay, and here let g of x equals 4x minus 5, and we need to find the indicated value g of x. What is g of x when x equals to 2? I'm going to substitute x for 2. So when x is 2, g of 2 is 3. So we could look at it like this. 2, g of 2, 2, 3. Guided practice. Again, what is the value g of x at negative 10? Just take 4x minus 5 and you substitute negative 10 for x. You do the math. 4 times negative 10 is negative 40. Minus 5 is negative 45. Now, what if I give you the value of g of x as 19, and I want you to find the x coordinate? Still do the same thing. G of x equals 4x minus 5. G of x is 19. And I can solve for x. You add 5 to both sides of the equation. And this would be 24 equals 4x. And x will go to 6. Graphing a function is the same thing as graphing a linear equation. So here I have for you graph using x and y intercepts from 8.3, or use the slope-intercept 8.5 method. For this example, I am going to use the x and y intercepts. So again, I told you earlier, f of x is actually just equal to y, the output. When y is 0, what's x? So we're going to calculate this. 0 equals 2x minus 4. X equals 2. So the x-intercept is 2, 0. And the y-intercept, that's when the x equals to 0. Y equals 2, 0 minus 4. It's just negative 4, so my y-intercept is 0, negative 4. And I can graph. Gonna label my points. And 0, negative 4. 2, 3, 4. And I can graph. Okay. Now, I'm going to erase this. For the next problem, I'm going to use the slope-intercept form. So I know my y-intercept, b, is 0, positive 3. And my slope is negative 3 over 2. As you can recall from 8.5, we need to first graph the y-intercept. And I'm going to plot the point 0, 3. Okay. Now I'm going to look at the numerator, which is just represented by the difference of the y coordinates. And because it's negative, I need to shift down from the y-intercept 3 units. 1, 2, 3. And I'm going to look at the denominator. It's positive. And I'm going to shift right, because it's positive, 2 units to find my second point. And I happen to land on the point 2, 0. And if you're unsure if this is the right point, you can always double check to see if the slope is still negative 3, 2. 3 subtract 0 is 3. 0 subtract 2 is negative 2. Yes. Or you can plug in 2, 0 into this equation. So if I plug in 2 here, negative 3 plus 3 is 0. So yes. And I can connect my dots. Writing a function is the same thing as writing a linear equation. So when you're given a problem like write a linear function g, given that g of 0 equals 9 and g of 3 equals negative 6, you can conclude that for the first point, the x-coordinate is 0 and the y-coordinate is 9. Basically, these two functions are just a formal way of representing coordinate points. Formal. And for the second point, the x-coordinate would be 3. And the y-coordinate would be negative 6. Now we have 2 points. And this goes back to 8.5. When you're given 2 points, you can find the slope. Negative 6 minus 9. 3 minus 0. Difference of y over difference of x. Then you get negative 15 over 3. And your slope will be negative 5. And notice here I have a y-intercept of 9. So b equals 9. So now I have two important pieces of information. I could use the slope-intercept form again. Y equals negative 5x. And since 9 is positive, I can just go ahead and write plus 9. And that would be my linear equation. And I will need to change y to g of x equal to negative 5x plus 9 to be more formal. I use g because the function is represented by g. G. Okay, to be consistent. Meaning, this doesn't mean that the function is always going to be g. It just depends on what the problem gives you. And usually f is the letter we use. And here, let's practice one more time. Again, you have g as the letter. Negative 6, 16. And you get 0, negative 5. And the slope. Negative 5 minus 16. And 0 minus negative 6. So you get negative 21 over 6. This would be negative 7 over 2. You gotta simplify the fraction. Now again, here we have a y-intercept of negative 5. And we can write our equation with using the slope-intercept form. Y equals mx plus b. And y is negative 7 over 2 x. And then because it's negative 5. And remember to change this to g of x equals negative 7 over 2x for formality. Okay? Gotta use g. Because it's g here. Okay, let's do one more problem. Okay, pay attention. It's r now. They're using r to represent the function. Negative 7, 3, and 0, 3 are your points. The slope will be 3 minus 3, 0. So the slope is 0. Now again, slope-intercept form. Get into the habit of using this. So my slope is 0. My y-intercept happens to be positive 3. Y equals to 3, and since the problem started out with the letter r to represent the function, you can do r of x equals to 3. Okay, word problems. We're going to use the function notation in real life. So, for example, cable TV, the average monthly cost of basic cable TV was $9.73. So every month, if a person signs up for cable TV, they will have to pay the basic monthly cost of $9.73. And this began in 1985. And since then, it has increased by about $1.35 each year. So this is like a rate. Okay. Let T be the number of years since 1985. Okay. Use a function notation to write an equation giving the monthly cost of basic cable TV as a function of T. So we know that the price increases by $1.35 per year. So I could represent that as $1.35 T. And the basic cost per month is $9.73. And I could set up a function for this situation. So one more time, you need to pay a monthly cost of $9.73, and every year the price increases by, or at a rate of $1.35, and you got to multiply it to t. And that's our answer, this one. Okay, let's do another word problem. After the balloon described on page 448 in your textbook was launched, it rose at a rate of about 500 feet per minute to a final altitude of 120 feet. So the first thing you need to do is use a function notation to write an equation giving the altitude of the balloon as a function of time. So for A, I'm going to let t equals time in minutes. And A just represents altitude. B, the altitude, how high the balloon rose. So and it says here that it rose at a rate of 500 feet per minute. So this should be your slope. Okay. 500. Okay. And then time, rate of climb times the time, t. And the final altitude is 120,000 feet. So in part B, it asks you how long did it take the balloon to reach its final altitude. So we can substitute A of t for 120,000 feet. And after we do the math, divide both sides by 500, we should get 240 minutes, or about 4 hours. So basically there was a hot air balloon. It just rose and rose to an altitude of 120,000 feet from ground level at a rate of 500 feet per minute. So as you can see, the rate actually represents the slope. Okay. And that concludes our lesson.